There's a fantastic Icelandic poet, Halldór Laxness, who has a quote that begins, "Where the glacier meets the sky, the land ceases to be earthly, and the earth becomes one with the heavens." And this description of this sort of melting and merger between the earth and the heavens is really an experience that you have when you're in Iceland. And when you're walking over the highlands and there are no houses, there are no sounds other than the wind racing over these otherwise barren landscapes, that on one hand it can seem bleak, but it actually encourages the imagination to be able to dream and to design and to be able to think about things in a different way. And it's an opportunity, even if I'll never have an opportunity directly to go to Mars or another planet, where you're transformed in your imagination from being on Earth to being in this other world, in this other landscape. My name is Christopher Hamilton. I'm an associate professor at the University of Arizona's Lunar and Planetary Laboratory, and I'm the principal investigator of the Raven project. I'm a planetary volcanologist, and at the moment I'm in Reykjavik in Iceland, and I'm here on a Fulbright Iceland Fellowship to be able to work with colleagues at the University of Iceland and to be able to begin developing some of the foundational work for the Raven project. What we're interested in the context of Raven is to be able to start testing new technologies and new environments where we could use a drone, in particular to access these previously very difficult and in fact probably impossible to explore on the ground environments. And so if you're interested in understanding volcanic terrains in a cold environment, which Mars is currently, then Iceland is really the best place that you can go to answer those questions. Large eruptions are really the key to being able to understand the volcanic history of Mars. In Iceland, just a few years ago, there was a new eruption in the highlands called Holarhraun. And the moment I saw it, I knew that this was going to be a really important event and a very useful and valuable analog for Mars. Drones offer more than just the ability to take pretty pictures from the air. And so there are a number of different ways in which rovers and drones can work together to be able to do things that wouldn't be possible by either system alone. So one of the really exciting things that our Raven project will have is a Raven Claw. And so this will be a sample acquisition device, and we're going to try a few different designs, scoops, and also different types of drills that will let us use the drone to fly to a new location, acquire a sample, and bring it back to the rover, and then let the rover's scientific laboratory perform the types of sophisticated measurements that we need to be able to answer the really tough questions for Mars.
To have a drill that actually would drill on a lava flow, on a young lava flow of Mars, that would be, I think, one of the most exciting things that I could imagine. We have two types of drones that we normally use at the Holarhraun eruption site. One is a quadrocopter that you can pilot yourself. We also have a fixed wing that we call the little beastie because it's going to cover a lot of ground with a very high resolution.
We also want to test out what you could do with different types of cameras. So we'll be able to consider different wavelengths through hyperspectral cameras, thermal remote sensing cameras, and we'll also be able to use different types of instruments like lasers or LiDAR to be able to develop topography.
This is footage inside of a volcanic vent that erupted in Iceland in 2014 and 2015. And we acquired data to get a 3D model of it.
So airborne imagery gives us the one type of data that we can use to examine surface properties. The colors of the surface tell us things. We can also construct stereo models or 3D topography.
Raven includes quite a few opportunities for students, and one of the really exciting ones is that we'll have a number of students actually developing from beginning to end a science operations plan that they just wouldn't be able to do with a regular Mars mission.
It's good.
going to be a PhD thesis. Being involved in the whole process, how to get there, and even maybe influence a little bit what kind of scientific workflows would be required and decide which instruments on the drone would make sense. I think that's a huge privilege.
On February 18th, the Mars 2020 mission will land in Jezreel crater, and this mission includes two components. The first is a rover called Perseverance, and the second is a helicopter, which is a technology demonstration called Ingenuity. And this is a really exciting opportunity because for the first time, this vehicle will be able to demonstrate flight on another world. And in doing that, it will open a whole new paradigm for how we can use similar technology scaled up to be able to travel further, bring more instruments, and to be able to answer really new questions, because we'll be able to demonstrate that if you can fly to new locations and acquire data on Mars, you can answer questions that would never have been possible on the ground before. I think the thing that really makes Raven particularly exciting for me is that it's an opportunity to build on my own history of being able to have been a geologist, to be able to have spent time in different volcanic landscapes to try and understand them on our world, and to be able to get a little bit of a deeper appreciation of what these types of volcanic terrains would be like elsewhere. And so Raven itself is able to fill a very important role because drones are going to be an integral part of, in particular, how humans explore Mars in the future. Being in the field and being in these aspects of nature that challenge you to be able to think differently. How could I be more efficient? How could I explore this environment? What would it look like from above? Are actually some of the key motivators that enable us to, I think, do better science and to be more creative when we try to approach these problems when we're exploring other worlds as well.